Hi, welcome to my video on the diagonals of a rectangular prism, or we call it a box. The diagonals of a box is a segment drawn from one vertex to another, not along the face or the side of the box. So a diagonal could be G going down to D, it could be H going down through the middle to C, or it could be A going down to F, or it could be B going down to E. The diagonals in this box are, it could be A, F. We could also have H, C. It could be G, D. And it could be B, E. That's the four diagonals. And this rectangular prism or box, all the diagonals are equal. All the diagonals of the rectangular prism or box are equal. And to illustrate that, I have a diagram here that I have drawn, but I have one made up that looks identical to it, so you can see the P and the V, the Q and the R and all the sides. And why I made it up, because I want you to look down through it and see the YR, which is the bottom diagonal, going from Y to R. That's the red line on this diagram here. And you can see that when you look down through, the bottom of the box is a rectangle. And the triangle, the diagonal of the rectangle forms a right triangle. And that's this triangle right here. And if you look, this is the height of the box coming up. And if you put this green, I have a little green line here, that's one diagonal. That's another diagonal going from the top to the bottom. Or I can do this one here. So there's four of them. To illustrate, I have the four diagonals to represent. Okay, let's continue. That box was just an illustration that I made up. But if we take the bottom of the box, there's a right angle there, and there's the right angle at Q, and the width right here is that width. The width is equal there. VT is width, PQ, PU is the width, QY is the width, and the length is QR, and that's the length over there. And the height is, these are the heights. This is the height. The height of the box is going up. So in this triangle YQR, we have a length, and we have a width, and we have this diagonal, which I'm going to call just D right now. And we have a Pythagorean, because we have a right triangle, the Pythagorean property is working. C is opposite the hypotenuse. C is the hypotenuse opposite the right angle. So D is the C. The L and the W are the two legs. And so we have in relation to the length and the width of the bottom of the box, we have a Pythagorean property written down. So let's continue with the diagonal is UR, which is right here. That's the diagonal of the box. This is the diagonal of the base. This is the height. And so this triangle I have here, UYR, is this one I have traced outside. There's the right angle right here on the bottom, at the bottom corner of the box. And UY is the height, and the diagonal D that I found, y squared is L squared plus W squared using Pythagoras. That's the D right here, that's the red line. And this is the large diagonal of the box that I'm going to call diagonal large. That's of the box. So we don't. This is the diagonal of the bottom or the base, so we can call that. And this also leads us to Pythagorean because we have a right triangle. So this large diagonal of the box is made up of the h squared plus this square right here. And if we, that's a square on that because it's c squared, so the dl squared, h squared. But this diagonal of the bottom is made up of the length and the width. So d squared equals l squared plus w squared. I replace the d squared with these two from this equation here. So the diagonal of the box, the large diagonal, the diagonal of the box is made of the square root of h squared plus l squared plus the w squared. And if you want to put it as a d in terms of the box, then let's put it in order. L squared plus the width squared plus the height squared. So the three dimensions of the box, the length, the width, and the height, the square root of all of those squares is the length of the diagonal of the box. So that's a quick way to do it. So the diagonal of the box is the square root of the length squared plus the width squared plus the height squared. So let's go on and do an example of that. We have a box here that has the bottom is a 4 and a 3 in length and width, and we have a height of 12. The unit is meters, and I want to find the length of AB, and AB is the diagonal. So if we find the diagonal of the box is the square root of the length squared plus the width squared plus the height squared. So the length is 4, the width is 3, and the height is 12. And if we work these out individually, square them first, bed mass, 16, 9, 144, and that leads us, let's go up right here, the square root of 169, that's a 169, which is 13. So the length of the diagonal is 13. So AB is 13 meters long. So what happens if you forget that formula? Well, I'm a believer that why not work it out individually? In other words, let's do this. Let's draw this diagonal right here and draw the diagram, the triangle for the bottom. So it's H, E, B. And if you do it this way, this is the shortcut, which is great, but let's draw H, E, B, right angle, and that's a 3, because the widths are the same, so that's a 3 and a 4, and let's call this x. So c squared is a squared plus b squared, which is the Pythagorean property. X is the hypotenuse. The c is opposite the right angle. The hypotenuse is the longest side. A is 3, b is 4. X squared is 9, 3 squared, 4 squared, 16. X squared is 25. X is the square root of 25, so x equals 5. Now, if we draw the big triangle, which is A, B, H, so this is this triangle, A, B, H, with a right angle at H. So the height is 12, so that's a 12. AH is 12. The bottom of the box is, we found out to be 5 from this one right here. That's a 5 worked out in the triangle HEB. And we need to find the length of the diagonal, which is the AB. So D C squared is A squared plus B squared. I always write this down. And then I say, where's the hypotenuse opposite the right angle? So that's my D. And I have a 12 squared plus a 5 squared, A and B. So D squared is 144 plus 25. D squared is 169. When you add them up, D is the square root of 169. So D is equal to 13. So you can find it by using the square root, the formula here, or you can work them out individually. Work with the diagonal at the bottom and then work with the diagonal of the other triangle going to the middle. So that's an examples, working with the diagonal of a rectangular prism. Let's do some practice, more practice. Practice means, for me and for you, pause the video, read this problem, write it down, pause the video, and then see if you can work it out to get the answer. When you get it worked out, play it back to see if you got it right. And do it for each one of these. Do them one at a time. Here we go. A rectangular prism or box has a length of 8, a width of 6, and a height of 24. Find the length of the diagonal of the box. So if you draw a diagram of the box like this, here's the box, and you keep drawing these enough you get used to them like I'm doing. The length of the box is 8. The width of the box is 6, if you call that longer than that. And the height of the box is 24. Not drawn to specs. You can see the height is shorter than the width, but I don't have enough room to draw to specs. And the unit is inches. Find the diagonal. So the diagonal of the box goes up. There's the diagonal of the box from the top corner to the bottom corner. And what we do too, we draw the diagonal of the base because there's a right angle here. So let's draw. We don't have to do that. We could if we want. Say, I know the formula. The formula for the diagonal of the box is the square root of the length squared plus the width squared plus the height squared. And that would be 8 squared plus 6 squared plus 24 squared. So 8 squared is 64, 6 squared is 36, 24 squared is 576, and all together, when you add with a calculator, is 676, and so the diagonal of the box, square root of 676 on your calculator is 26. That's working it out with knowing the formula. Square root of length squared plus width squared plus height squared. Or you can work them out individually. I like to work them out individually. Just, I'm old-fashioned. Sometimes I forget the formula. But the bottom is a right angle, and that's a 6 and an 8. And I find this hypotenuse of this triangle. So C squared is A squared plus B squared. And that's X is the hypotenuse opposite the right angle. 8 and 6 are the two legs. And that's a 64 plus a 36. X squared is 100. X is the square root of 100. And X equals 10. So we found this diagonal of the base to be 10. Now I'm going to draw the other triangle that I have here. And that's a height of 24. The distance along the bottom is 10 that we found out right here in this triangle right here. And we need to find the length of the diagonal of the box, which is from the top corner to the bottom corner on the other side. So we got C squared is A squared plus B squared. The right angle is right there at the bottom, so that's that one. And the hypotenuse, C is the hypotenuse opposite the right angle, so C is replaced by D. A is 24, B is 10, and we square them. d squared 24 squared is, what is 24 squared? Well, that's 100. Let's use our heads. And that's 100, so that's a 576 if you use your calculator. So d squared and adds up to be 676. So d is the square root of 676, and that comes out to be a 26 in length. And the units are in inches, so that's inches, and that's inches, and that's inches. Again, use the formula or work them out individually with the two triangles. Now we have another one. Pause the video. You can see the problem. Pause the video, write the formula down, or write the problem down, sorry, and work it out, and then play it back to see if you got it right. It says the bottom of a rectangular box has dimensions of 12 and 9. The diagonal of the box has a length of 39. Find its surface area. Now, to get the surface area of a box, I need all sides. I have the bottom of the box. Well, let's draw the box first. Let's see. Always draw the diagram because it gives you an idea of what's happening. So here's the box. Drop that down so you can get the three-dimensional idea. There it is. So the bottom of the box is 12 by 9. Length, and I could put 12 here and 9 there. Don't make a difference. The diagonal of the box is 39. So 39 is that one right there. 39. Okay, and all the units are centimeters. So to get the surface area, I need the length, the width, and the height, but I don't have the height. But I do have the dimensions of the bottom. So what we're going to do is draw the triangle that's on the bottom. And that's a 9 and a 12. That gives us this diagonal here. Let's put an A and a B on that. So that's an A and a B. So I'm getting the length of AB. So C squared is A squared plus B squared. X is my C, because XC is opposite the right angle. And so X is my C. 12 and 9 are the other two sides. So X squared is 144 plus 9 squared is 81. X squared is, that adds up to be 225. X is the square root of 225. So X is 25. So, I said 225. I'm not thinking now. The square root of 225 is a 15. Sorry about that. So that's 15. So the diagonal at the bottom is 15. When I was thinking about 225 then, the square root of 625 is 25. 250. Square root of 215 is a 15. Square root of 225, sorry, is 15. Now we have another triangle. We got to get the height. So we have a triangle that's A, B, H. So we can draw it that way. Don't make any difference. I got an H, I got an A, and I got a B. I got a right angle in the corner. So there's the height. The diagonal is 39, which is AH, and the AB that we just found is 15. And again, we use our Pythagorean on this because we have a right triangle with two sides. C is 39, opposite the right angle. A is the H, the height, and B is the 15. So 39 squared is, what is 39 squared? It's 1521 when you do your calculator. H squared is, that's a 15 squared, forgot to put the square in. 15 squared is over here, 225. So H squared is 1521 minus 225. So H squared is 1296. So H is the square root of 1296. h squared is 1296. Oh, h squared is 1296. H is the square root of 1296, so h is 36. So the height of the box is 36. Now we need to get the surface area. So the surface area of a box, rectangular prism, is you have the length times the width. So that's the bottom, the length and the width, but there's two of them. You also have the length times the height. The length times the height is this face here, but there's also two of them. And you have the width times the height, which is the front of the box. So the width times the height, and there's two of them. So you fill all this in. 2, the length is 12, the width is 9. The length is 12, the height is 36. The width is 9, and the height is 36. So you just say that's the width, and that's the length, and that's the height. And when you got all that filled in, you use your calculator and you multiply these out. So 2 times 12 times 9 is, calculator, 216. 2 times 12 times 36 is 864. 2 times 9 times 36 is 648. Use your calculator. And when you add all those up, you get a 1728. And again, this is in centimeters, so that's the length. This is in centimeters, so that's the length. But this is area, so this is square centimeters. So I used the diagonal of a box to work out the surface area. That means you're using many more ideas, and you're reviewing and learning all the time. You're using Pythagorean. The more ideas you can bring in, the more you review the concepts or ideas of math, the better you'll be able to work them through correctly. And if you like my video, click the like button, the subscribe button, and click the notification bell if you're a subscriber. Write a comment on my video if you wish, and visit my math website at mathfullyexplained.com, and there you'll find information on me, my videos, the strategies you're going to use to help you learn your math, and you find the content that I have online already, and there's more content to be done in the near future. Thank you very much. Bye-bye.